Okay, so let's start it. Yeah, let's start it. In this session, we are going to discuss Snowflake full stack, and we are going to discuss what are the concepts we are covering as part of Snowflake full stack, and what is the role of each component or uh, each uh, component in full stack team. So first we start with Snowflake master Snowflake. So uh, Snowflake main purpose is it's a modern data warehousing tool. It's a modern data warehousing tool. It can be used to store huge volumes of data sets, and it supports. It's a cloud-based data warehousing tool, and it supports three clouds. So first one, let's understand about Snowflake. So Snowflake is a modern data warehousing tool. It's a modern data warehousing tool, and it supports three clouds. It supports AWS, it supports it supports Azure, it supports GCP. First one, it's a cloud-based modern data warehousing tool. It supports unlimited storages. It supports unlimited storages, and backend it's supporting three different clouds. Let's say first one, Snowflake, Snowflake, and here it's supporting three different clouds: AWS, Azure, and GCP. Three different clouds. While creating account, while creating account, so we will use Snowflake URL, and we will select a cloud tool. So let's say I want to choose AWS cloud. You may choose Azure cloud. Someone choose GCP cloud as Snowflake backend cloud. But performance wise, there is no difference in cloud team. So because complete data processing storage is taken care by whom? Snowflake software. Okay. So in Snowflake, we store the data, and we perform transformations, and we store transformer data into transformer table. Then once we apply transformation, data consumers like Power BI, Tableau, or ClickSense, or machine learning people, or artificial intelligence people takes that output of a Snowflake, and then they will do operations. Let's say if it is data analytics people, they are going to generate reports and dashboards. If it is ML machine learning people, they are going to do predictions, future predictions on data. Okay, so first important one is this Snowflake. Snowflake is a cloud data warehouse. It supports three clouds. Right now, it's supporting three clouds: AWS, Azure, and GCP. While creating account, we can choose required cloud. Okay, so let me open one more paint, and let me explain. So first one, this part is Snowflake. Snowflake. Okay, let's say this one is Snowflake. Snowflake. Okay, and here we have different data sources too. Let's say different data sources. Different data sources too. Let's say these data sources may be files, maybe flat files, maybe any RDBMS, or any NoSQL databases, any NoSQL databases, or any cloud file systems, or any data warehouses. Okay, so any data warehouses or SAP or SAP systems or any data team, any data, any data. So let's say team here. Important point is there is one role team. There is one role. So role is data ingestion role. So what this data ingestion people do is they will connect different data sources. They will connect different data sources. There is one role, data ingestion role, data ingestion role. Someone is unmuted. Please mute team. Data ingestion role. One minute. One minute. Yeah, I think someone is unmuted. Yeah. Data ingestion role team. So data ingestion people, they may use either Python, they may use Spark, they may use any data ingestion language. And what they do is they will connect the different data sources. They will connect the different data sources and they load data into data lake. They load data into data lake. So data ingestion people connect with the data sources and they store data into data lakes. So data lake may be AWS S3, data lake may be AWS S3, data lake may be Azure Blob, data lake may be GCP storage, Google Cloud storage, or Google Cloud file system team. It may be anything. Okay. So data ingestion people connects with the data sources and they perform data ingestion and they store the data into data lakes. This is one way. Other way, we can apply Snowflake connectors. We can connect with the different data sources and we can load data into Snowflake. These are two different approaches. But maximum this approach is happens in real time. This approach is happen in real time. Maximum projects are happening in this way. So data ingestion people, they may use Python, they may use Java, they may use Scala, they may use .NET, they may use Spark, and they connect with the different data sources and they load data into data lakes. Maximum data lakes are nowadays, maximum data lakes are AWS S3 or Azure Blob or Google storage, Google file system. So data ingestion people do this activity and once data is loaded into AWS S3 or Azure Blob or GCP cloud stages, then we come into picture. We means Snowflake Developer. So we are going to connect with this data lake or data sources, and we load the data into raw tables. Raw tables. So this one is raw tables. We load the data into raw tables. Then once the data is loaded, we are going to apply transformations. We are going to apply transformations. We are going to apply transformations on raw data. Transformations. Based on the business requirement, we are going to apply transformations to. And then once the transformation is completed, we store the data into transformer tables. We store the data into transformer tables. So once transformations are success, then once the transformations are success, then we load that transformer data into transformed tables. Okay. So here we convert raw tables to transformer tables. Okay. So we apply different transformations based on the business requirement. We apply transformations on the raw tables and we convert into transformer tables. Tables. Okay. So this one become input to this transformed tables become input to data analyst. So these transformer tables are become input to either data analyst or machine learning people or artificial intelligence people team. Is that clear team? Any questions here? Sure. Yes. 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 Yeah. So you are thinking, so are we use, they may use same our AWS S3 account or no? First point, let me clarify here. This one you need to have a clear clarity here. So here Snowflake backend is using AWS. AWS or Azure or GCP. This is nowhere related to this one. Yes, yes. Let me give clear clarity here. Let's say this is my business. Let's say we are working for XYZ client. XYZ client. Let's say we are working for XYZ client. XYZ client, what they are using? They are using their own cloud. They are using, let's say, these people using, assume these people using AWS or Azure or GCP. Let's say this one is AWS or Azure or GCP. Assume they are using AWS. So here, what these people are doing, these people using AWS S3 service for their business purpose. Assume some services I'm listing to AWS S3 they are using, and they are using AWS RDS. They are using AWS Glue, and they are using AWS SageMaker. What is the purpose of each service is different. Just we are discussing. Assume XYZ client is using AWS cloud with different service system, and they are using AWS Bedrock. Bedrock is generative AI service, and they are using AWS Redshift. Assume they are using these services in AWS cloud for their business. Let's say their application XYZ application is e-commerce application. E-commerce application. E-commerce application they are using, and they are using these services for their e-commerce application. This is different. Okay. And now let's see same XYZ client using Snowflake data warehouse. Snowflake data warehouse. Snowflake data warehouse. Here, these people backend they may use any one of the cloud. They may use AWS, they may use Azure, they may use GCP, any one cloud, right? This part clear, right? So backend they are using any one of these cloud. Snowflake people using any one of this cloud. This one is Snowflake. So for backend purpose of Snowflake, these people using any one of this one, but this cloud account is different. This is different. These are maintaining by Snowflake people. This is maintaining by our client. For data storage purpose, these e-commerce people may using this Snowflake. Are you getting my point? Either direct inserting or through any one of these services, they are inserting data into Snowflake. Okay. So this account is maintaining by Snowflake people. This account is maintaining by our client. Okay. So here data ingestion people may come into picture. Data people may come into picture. Data ingestion people. Data ingestion people. What data ingestion people is doing, they are connecting different sources. Just now we discussed. They are connecting different sources, different data sources. If our client is using S3, here our data ingestion people are storing data into S3. From S3, what we are doing? From S3, we are storing into Snowflake raw tables. You are getting my point, right? Okay. Yeah. Okay. Yeah. So this part is clear, right? This part. So here data ingestion people, they may use Python, they may use Java, they may use Spark, they may use .NET. They connect with the different data sources. They apply business logic here and they load data into data lakes like AWS S3 or Azure, Blob or GCP, depends upon our client data lake. And once it is presented in data lake, as a Snowflake developer, we may use techniques like load technique to connect with different data lakes, and we load the data. Or we have a option, Snowflake itself providing option to connect with different data sources, connect with these data sources, and we can connect with these data sources, we can load the data. Let me open our Snowflake cloud. Let me show you so that you may get some idea. So this is my Snowflake web URL, and here I am entering my username and I am entering password. So this is my this is my Snowflake web UI environment. This one, this one. This Snowflake web UI URL I'm connecting here. Here you can see, click on data, add data. You can load data from your local system to table. You can load data from AWS S3. You can load data from Microsoft Azure Blob. You can load data from Google Storage. And also it providing more connectors. Click on more connectors. You can see lot of connectors to connect with different data sources. Different data sources, and you can load data from different data sources to our Snowflake tool. You can click on this one. You can explore all the connectors. See, so you can connect different data sources directly. You can connect with the different data sources directly, and you can load the data. Okay. So there is a separate data ingestion role. This data ingestion people connect with different data sources, applies business logics, and loads the data. This is one approach. And second approach, as a Snowflake developer, you can connect with the different data sources. You can write a load logic, and you can load the data into raw tables. Once data is presented in raw tables, you are going to apply transformations. These transformations you can use uh, in Snowflake. You can apply transformations using Snowflake SQL, Snowflake SQL, and procedures. You can write procedures, UDFs, etc. UDFs, etc. Then you can apply transformation logics. So first one, we need database here. We need a database. We can create a database. We can create a schema. We can create tables or views. On that we can write SQL queries. On that we can write SQL queries. We can write to procedures. We can write user defined functions. We can apply user management. You can apply uh, optimization techniques. Multiple things as a Snowflake developer we can do on raw tables, and we can form a tables. This is one way. And second approach team, second one is DBT team. DBT. DBT. DBT stands for data build tool. Build tool. So data builder tool meant only for transformations team. It meant for only transformations. With the DBT tool, you can do only transformations. So let's say I said here we have the data. We have the data. Here we can use, here we have data consumers, data consumers, data consumers team. So data consumers like like Power BI or Tableau or any uh, any data analytics team. They can connect with this transformer tables. They can generate what? reports and dashboards, or machine learning people. Machine learning people. These people performs uh, predictions, future predictions, or artificial intelligence people. So these people are consumers for our transformer data, Snowflake data team. Okay, so these people connects with our Snowflake, and they are going to generate dashboards, and they are going to predict future using different algorithms too. Okay, so let's say here, what is the role of DBT team? So DBT performs purely data transformations. It meant only for performing transformations too. DBT performs transformations. Except the transformations, it cannot do anything. It's meant only for transformations. Advantage, if you go with Snowflake with DBT, first one, we write a code. So first advantage why we are going for transformations is, first one, we can develop a code. We can write test cases, unit test cases using DBT. We can also develop documentation, and it also contain deploying code, and also it contain easily integration with the CI/CD tools. You can easily integrate with any version control system, and also it contain additional logic of lineage graph. Lineage graph. What is lineage graph is, let's say you created different transformation logics on different tables. You created different transformation logics on different tables, then it will generate a graph city. Let's say 100 raw tables are presented. On 100 raw tables, you applied around 100 plus transformations too. With all transformations, one transform may connect with multiple tables, another transformation may connect with different tables. You may apply to different join conditions. With all that information, it will prepare a graphs. What is the advantage of this lineage graph is, whenever you are doing any change on any transformation, it will give that impact on different tables. So by seeing lineage graph, you can identify what is the impact of new code, and you can easily integrate with CI/CD tools so that you can move your code from dev to test to production. And you can generate a nice documentation so that new developer cannot face while they are working on transformations, and lot of other activities too. So DBT mainly meant for performing transformations too. Any question yet? No, right? Okay. Yeah. Now let's discuss one more component we are going to discuss as part of Snowflake full stack is Snow Park. Snow Park. Most of the people think this is a alternative for Spark. It uses capabilities of Spark. It is not alternative for Spark. It uses
Okay.
capabilities of Spark. Yeah,
Yeah, I had a quick question, but sorry to interrupt you. So basically, you
no
told like
problem.
in the data build tool,
Hmm.
we'll be using code, right, to do some transformations. Like, what code do we use, like JavaScript or Python? What uh, what code do we use for these transformations?
Okay, okay, got it. So we are use, not going to write uh, programming techniques, too. Not write a programming style. Programming style. It provides simple SQL type. It uses SQL kind of queries, not programming style. We are not going to write JavaScript. We are not going to write a Python code. We are not going to write Java style of syntax. But here we use SQL statements. First one, we use SQL statement. Along with this one, they provide one more important one, Jinja template syntax. Jinja syntax, Jinja template logic. It look like a JSON thing. It's look like a simple JSON kind of things. On top of SQL, we apply Jinja logics for looping purpose, condition purpose, to specify table or view. For configuration purpose, we use Jinja syntax.
Okay.
Jinja syntax comes here in this way to curly braces. Here we write a simple Jinja technique logic on
Okay.
top of SQL statements. Yeah.
And also one question, can you go back to your architecture diagram? But I was trying to ask a question,
Sure.
but I think my voice is
Sure.
not able to
Sure.
get to you.
Sure.
So when you load data from data lake, somewhere like Azure Blob Storage, or we give some file path or something to integrate the data, right? So first thing, the data will be loading into the raw table, and then we'll do a transformations and then load to the final destination table. So for
Yes.
each transformations, like for raw table, the table will be created, right? So for each thing, do we use a separate database? Suppose in the SQL, when we try to load using SQL, we have the separate database, right? Like what we say, so separate database for SQL. We load the raw data into one database, and then
Yes.
while we load the data in final destination, we load into the exact CD. So the same
Yes.
way, do we create separate databases for
Yes.
raw data loading and the final destination table, or we can do all in a single database itself?
Oh no. Oh, we don't do in a single uh, database. We will create a databases like raw databases, stage databases, and final actual business final output database. We create
For the
three kinds of
and for the transformations, we create one more table in between the raw and the original table, right?
yes, yes, yes.
Okay.
Temporary results we persist in stage area. Once we confirm complete transformations are successful and loaded complete information in expected results in stage data, then we move that stage data into final transformer tables. We create different databases. We have a separate topic in Snowflake. First, we talk about databases and what is the purpose we create databases and schemas. And then we are going to work on tables, views, procedures,
Okay.
UDFs.
Yeah. Got it.
Okay.
Got it.
This one is a rough and overview of how we are going to work.
Got it.
Okay. Yeah.
So in the
Now,
going classes, you'll be going through each one, right? But
yes, yes. While this one is initial classes, we are understanding what is the responsibility of Snowflake developer, dbt developer, and snowpark developer, airflow developer. So we are talking about Snowflake full stack, right? And what is the purpose of each component? Main important component is this one, because it's a central store where we are going to store our raw data, transformer data. In between raw data, transformer data, what we are doing? Using dbt we are going to do. First one, we are going to do with Snowflake itself contain different features to perform transformations. And we are going to use dbt for same for transformations. What is the benefit we are getting with the dbt? Just now I explained. Here, I explained it contain code. We can write unit testing. We can develop a documentation. We can deploy. We can easily integrate with the CI/CD, and it provides additional feature called lineage. And it also provides one more important is called reusability, code reusability. These are many benefits we get with the DBT when you go for transformations. And one more important point, thing, one more important point. Most of the time, we may hear the term ETL or ELT,
ELT.
ELT, extract, transform, load, or extract, load, transform. So most of the time nowadays we are working on ELT operations, extract, load, and transform. This architecture thing. This architecture. We are extracting from different sources and we are loading into data lake, or we are loading into raw table. Then we are applying transformations and we are persisting into transformed tables. Okay. So here we understand Snowflake importance and we understand debate importance. Now let's understand about the Snowpark thing. Snowpark uses the capabilities of Python pandas. Pandas, we have a concept called data frame. So what we do with the pandas is, let's say we have a data. This may be CSV, this may be JSON. We have the data and we use Python pandas, and we read this data. We convert this data into tabular format called data frame. So we convert this data into tabular form called data frame. Data frame. Data frame. If it is smaller data, pandas is okay. If it is bigger data, what happens? It uses a single mission for loading the data. Single mission for loading the data. If it is bigger data, you may get out of memory issue. Yes or no? So to solve this problem, we have powerful technology called Spark team. Let's say PySpark. In PySpark also, we go with the concept called data frame. Data frame. We convert the data into rows and columns. We may connect with the different data sources, and we create data frame. We apply data frame operations. Data frame operations. This one will work with the single mission, but this one work with cluster. Cluster means collection of missions. Collection of missions. So it uses in-memory computing, in-memory computing, and it uses distributed computing. Distributed computing. Your huge volumes of data divided into multiple partitions. Each partition is going to process by different mission. So distributed computing team. If you want to apply distributed computing in Python and pandas, you have to write multi-threaded applications. Even if you write a multi-threaded application manually, that may achieve, that may not achieve your requirement, that may fail. You have to take in care a lot of things by writing multi-threading, but PySpark contain powerful distributed computing, in-memory computing. That's why industry going for this PySpark for huge volumes of data processing. Okay. Now let's understand. This is my Snowflake. This is my Snowflake. Snowflake. Okay. And here I am using PySpark. This is one of the popular implementation in real world. This is one of the popular use case nowadays. People are going here, and here it is having multiple clusters, multiple missions. Okay. Observe what is the advantage of our Snowpark compared to PySpark. Here we have in Snowflake. Here we have storage, and processing. Storage and processing. This processing we call it as virtual warehouse. Virtual warehouses. Here same kind of PySpark. This is using distributed computing for processing. That's why Snowflake is very faster for processing. It uses sizes like extra small. It contains only one mission, small, two missions, and medium, four, and large, 8. Here we have different sizes, different sizes. But if you use PySpark, your data going to move to these missions. Your data is going to these missions and parallelly distributing and processing. Performance wise, very faster, but your data is moving from your Snowflake to PySpark cluster and data is processing. And again, once the transformation is completed, it is storing into transformer tables. Let's say this one is raw and this one is stays, and again final transformer tables. So this one using raw and temporarily storing into stays, and finally it is storing into transformed. Getting point? Now, if we use Snowpark, if we use Snowpark, Snowpark, Snowpark provides language like support for Python. You can write Snowpark code in Python. You can write Snowpark code in Scala. You can write Snowpark code in Java. Currently, it's supporting 3 languages, but 90% of 99, I can say 99%, we go with this combination, Snowpark with Python, 99%. Okay. And here we write these kind of programs, Python kind of, PySpark kind of programs here. So we are utilizing similar style of PySpark style, kind of programming, similar kind of PySpark kind of programming. Here we write programs, data frame programs. And what Snowpark do, whenever you submit, submit, what happen is these programs are going to convert into SQL. These programs are converted into SQL. These SQLs are going to submit to your virtual warehouse. So it is submitting to Snowflake. There is no separate processing. We are not required separate cluster like a PySpark. We are submitting to virtual warehouse, which is presented in Snowflake. Snowflake is taking care. Your data is not moving out of Snowflake. Your data is presented in Snowflake. You are using capabilities of virtual warehouse, and this Snowpark is converting your programs into optimized SQL statements. Snowpark is converting your programs into optimized SQL statements and submitting to Snowflake Virtual Warehouse. Snowflake Virtual Warehouse is taken care, applies processing. Okay. Any question here, team? And with Snowpark also, we are doing transformations only.
So one question, but so what is the difference? Like DBT is also for transformation side, Snowpark. So one thing is the if the file size is larger, then we use the PySpark to load the file, right?
Hmm. No, DBT, Snowpark utilizing capabilities of Snowflake. But PySpark, your data moving from Snowflake to PySpark cluster. But DBT, Snowpark utilizing virtual warehouse of Snowflake. Your data not going to move out of Snowflake. You can go with either DBT or Snowpark. Who are
Okay.
strong in Python programming, PySpark, they like Snowpark. We have
Okay.
different transformation tools. Let me clarify one more point. I'm clearing this diagram team.
Yep. Yep.
Yeah. So first one, uh, this is my Snowflake warehouse environment. Snowflake. This is my Snowflake. Here we are creating raw tables. Let's say we have raw tables, stage tables, and final transformer tables. Simply transformer tables, let's say uh, uh, fact and dimensions table. Okay. So this one raw tables, stage tables, and this one is transformer tables. Okay. Here, first one, SQL Snowflake itself contain SQL concepts for performing transformations. This is Snowflake level. Snowflake itself contain different techniques to apply transformations. So you can apply this one on raw tables. You can temporarily store into stage area, and finally you can move. This is one. And other one we have DBT. DBT. If you use DBT for transformation logic, transformation purpose, you will get benefit of code deployment, testing, reusability, reusability of code, reusability of code, and documentation, and CI/CD integration, as well as lineage graph feature. Same thing you can achieve. Same thing you can achieve with DBT. If you go with the Snowpark, if you go with the Snowpark, you are getting capability of Python. You are getting Python kind of code you are writing. You are writing techniques like Python pandas, like data frame features, and PySpark kind of programming. Simply you can say you are using technique of Python style syntax for performing transformations here. And there are plenty of tools, Matillion. There are plenty of tools to perform transformations, but some are paid. These two are free. You no need to pay single rupee for DBT, single rupee for Snowpark. No, DBT providing cloud based, and other one is DBT core. DBT core is completely free. Okay. Snowpark is a API programming. It's completely free. Python is free. You can write Snowpark programs using Python. It's completely free. So it's utilizing capabilities of Python pandas and PySpark and virtual warehouse, Snowflake virtual warehouse. Okay. And final component as part of our Snowflake full stack is Apache Airflow for Snowflake team. Apache Airflow for Snowflake. Okay. So we return Snowflake SQLs. We return Snowflake SQL statements for database creation, schema creation, table creation, views creation, data loading purpose. We created multiple SQL scripts, multiple SQL scripts I developed as part of Snowflake development, as part of DBT. I developed some models, macros, snapshots, etc. Or I may use Snowpark. I developed different Snowpark Python files, py files or scripts. Snowpark 1 script, 2 script, and third script for applying. Then I'm using Airflow. Airflow, Apache Airflow. It's a free Apache Airflow. And here I'm defining pipelines. Define pipelines. Let's say first I want to execute this script first. And next I want to execute this script second. And next I want to execute this script third. If it is failed, I want to call this script. And then I want to call this script. Like that, I want to define a data pipeline. We go with Airflow, Apache Airflow. We are going to use Snowflake connectors, Snowflake. Here, mainly Apache Airflow, we use Python programming, Python kind of programming for defining pipeline. We can maintain logs, we can do exception handling, lot of activities we can do with Apache Airflow. So we are going to define data pipelines for Snowflake SQL scripts, DBT scripts, Snowpark scripts using Apache Airflow for Snowflake team.
Basically,
Is
Apache
it?
Airflow is something like total automation.
Yes, correct. Total automation for our jobs.
Yeah. Also, I have one more
Airflow,
question.
yeah,
So basically, from the using like Snowflake, we can load data up to 100 MB from the front end, I guess, right? So if the file is larger than that, we use PySpark, something like that to load the files, or how can we load those?
we can load any size of data. 100 MB concept is only direct loading.
Yep.
Just now I shown here one option, data loading. Let's say here add data. Here we are loading data into table, right? Here we have a
Yep.
250 MB size.
Yeah.
This is direct loading. We have different options. You can load any size of data. This is direct loading.
Okay.
Okay, direct loading from front end. Web
Okay.
user interface of Snowflake. But we have a different options to load any size of data.
Okay. So you'll be covering those concepts also,
Yes,
right?
yes,
Like if you,
yes.
yeah, okay.